Hello everyone, myself Dr. Preeti Yadav. I am a physics faculty in St. Andrews Institute of Technology and Management program. I am from Applied Science Department. Today I will discuss introduction of EM waves, their properties and their types from Unit 4 and the lecture number 20. Electromagnetic waves. As it is clear from its names that electromagnetic waves, it is a combination of electric plus magnetic. It is a combination of electric field plus magnetic field. Also, electromagnetic waves that are waves that can travel through the vacuum of a outer space. These waves, EM waves is a short form name of electromagnetic waves. EM waves are produced when electric field couples with the magnetic field. Means when electric field changes and magnetic field changes, they produce electromagnetic waves. Magnetic field and electric field of EM waves are perpendicular to each other and also to the direction of EM waves, means to the direction of propagation of EM waves. Now, production of EM waves. Firstly, electric field is generated with the stationary charge, and if the charge vibrates or changes, the electric field around it changes. Therefore there is a change in electric field, therefore it creates a changing magnetic field. And if the magnetic field and electric field create each other again and again, if electric field and magnetic field create each other, therefore they create EM waves. And EM waves travel in all direction, but in the figure 1 that are given below shows a wave traveling, means EM waves travel or propagation only in one direction. And the electric field and the magnetic field vibrate at right angles to the direction, and also the wave travels, it is a transverse wave. Here this red represents the electric field and this blue represents the magnetic field lines. And electric field along this direction, suppose this is X, this is X, this is Y, and this is Z. If magnetic field along X-axis and electric field along Z-axis, both are perpendicular to each other, and the wave propagate, means EM wave travel in Z direction. Here, this is the length of the electromagnetic waves. This represents the length of electromagnetic waves, and is the traveling direction of electromagnetic waves or propagation direction of EM waves. Now, what is the properties of EM waves? First is all matter contains charged particle, and we know that all matter contains charged particle. If there is a charged particles that are moving, always moving, means there is an electric field as well as magnetic field. If there is a electric field and magnetic field, therefore all objects emit EM waves. Next, the wavelength becomes shorter as the temperature of the material increases. Means the wavelength of the electromagnetic waves decreases, become shorter if the temperature of the material increases. Third is all electromagnetic waves are transverse waves. There is also representation of EM waves. This represents the wavelength. This is the node, as we know that this is a crust and this is struct, and that is the distance. This distance is known as the amplitude of the wave, and direction. This is the direction of EM waves, and this is the direction of the medium oscillation. Third, the electric field vector E and the magnetic field vector related by this, C is equal to, this is the relation between electric field and the magnetic field, where E naught and B naught are the magnitude of the E naught and B naught are the amplitudes of the respective field, and C is the speed of light. Here this is the electric field and this is the amplitude of the electric field E naught, and this is amplitude of magnetic field B naught. And the relation between electric field and magnetic field is C is equal to E naught by B naught. Here the representation of electric field along y-axis, magnetic field along z-axis, and the propagation of waves along x-axis, means propagation of EM waves or propagation of electromagnetic waves. The velocity of electromagnetic waves in free space is equal to C, means speed of light, that is equal to 1 by under root mu naught epsilon naught. Here mu naught is the permeability in free space and epsilon naught is the permittivity in free space. And the velocity of EMS in a material medium is equal to 1 by under root mu epsilon. Mu naught epsilon replaced by mu epsilon. Here mu is the absolute permeability and epsilon is the absolute permittivity of the medium. This is the velocity of EM waves in a medium, in a material medium. Seventh is electromagnetic waves obey the principle of superposition. Eighth is, as the electromagnetic waves move, they carry energy as they propagate through a space. Means if the electromagnetic waves travel from one point from here to there, they carry energy. Means they transfer energy from this point to this point. Means they transfer energy from source to the receiver or sender to the receiver. And this energy is equally distributed, because equally divided between electric field plus magnetic field, because the total stored energy in electromagnetic wave is equal to the sum of electric field energy plus magnetic field energy. Therefore, this energy is equally divided into electric field and magnetic field. Electric EM waves can transfer energy as well as momentum to objects placed on their path. If there is a object is placed here, then if the electromagnetic waves carry energy and momentum, then they transfer their energy and momentum to the objects that are placed on their path. EM waves do not require any medium to travel. Next is an oscillating charge which has non-zero access that can produce an electromagnetic wave, because the charge produce electric field and this electric field moving charge produce a magnetic field. If there is a electric field and magnetic field, then there is a EM waves. EM waves can all be reflected or refracted. This is any surface here. This is the incident EM waves. Incident here at a point this, then these waves reflected. This is the reflection of EM waves. Here, if EM waves incident in this medium, then there is a reflection of the EM waves. Sorry, refraction of the EM waves from one medium to the another medium. There is a reflection of EM waves in the same medium. EM waves can all be emitted or absorbed by the medium, by the matter or the objects. Frequency of EM waves do not change. Means frequency of when electromagnetic waves travel from one medium to the other medium. But speed and wavelength of the EM waves will change. Means wavelength and speed जो EM waves के वो change होगी, but there is no effect on frequency. Now the next is electromagnetic spectrum. As we know that what is electromagnetic, where all the lights are here. It is the complete spectrum or all forms of light. It is here in electromagnetic spectrum. There are number of waves. First is radio waves. Second, microwaves. Third is infrared waves. Fourth, visible light. Fifth, ultraviolet rays. Six is X-rays. Seven is gamma rays. Electromagnetic spectrum means it is a combination of all the wave rays. Here, chart of wavelength and frequency. This is the radio waves, then microwaves, infrared. These are according to their wavelength and their frequency, also their energy. And this is a long wavelength and low frequency. And here this is a short wavelength and high frequency. Number of cycles are more, but wavelength is short, and here wavelength is more and frequency is short. Therefore, radio waves has highest wavelength and low frequency, whereas gamma rays has highest frequency and short wavelengths. Therefore, these are according to their wavelength and frequency. This is the spectrum. Here, the first is radio waves, which has shorter wavelength. As we as we move from radio waves to gamma waves, here gamma rays, the wavelength decreases and frequency increases. These are radio waves in FM, TV, radar. This is radio waves. Infrared, whose wavelength is 0.01 centimeter to 1000 nanometer. And this is the visible spectrum. As we know that visible light that is seen by human beings. There are the colors that can be seen by a human beings. Means जो visible light वो है जिसे हम human beings देख सकते हैं. Means it is a combination of different colors. Next is ultraviolet rays. Its wavelength is 10 nanometer. Then X-rays. And after X-rays, there is a gamma rays. Now, in the next slide, I will discuss one by one all the waves. First, this is the chart of these waves. There is a frequency, wavelength, and energy of all the waves. First is radio waves whose frequency is less than 10 to the power 9, means radio waves whose frequency is low and whose wavelength is very high. Therefore, its wavelength is greater than 0.3. And the energy is less than 7 into 10 to the power minus 7. Now, next is microwaves whose frequency is 10 to the power 9 in 10 to the power 9 to 3 into 10 to the power 11. And whose wavelength is 0.0012 to 0.3. And energy of microwaves 7 into 10 to the power minus 7 to 2 into 10 to the power minus. Next is infrared, whose frequency is high as compared to microwaves, 3 into 10 to the power 11 to 3.9 into 10 to the power 14, and whose wavelength is less than microwaves, 7.6 into 10 to the power minus 7 to 0.001. And energy 2 into 10 to the power minus 4 to 0.3. Now, visible rays, whose frequency range is 3.9 10 to the power 14 to 7.9 10 to the power 14. And wavelength range 3.8 into 10 to minus 7 to 7.6 into 10 to the power minus 7. And energy range is 0.3 to 0.5. Ultraviolet and frequency range is 7.9 10 to the power 14 to 3.4 in 10 to the power 16. And whose wavelength is 8 into 10 to the power minus 9 to 3.8 into 10 to the power minus 7. And energy range 0.5 to 20. X-rays 3.4 into 10 to the power 11 to 5 into 10 to the power 19. and wavelength 6 into 10 to the power minus 12 to 8 into 10 to the power minus 9. And energy rays 22 3 into 10 to the power 4. And for gamma rays whose frequency is very high, 5 into greater than 5 into 10 to the power 19. And wavelength is less than 6 into 10 to the power minus 12 is very short wavelength as compared to all other waves. Is an energy is also greater than 3 into 10 to the power 4. And from here it is clear that radio frequency has less wavelength and less frequency as compared to all other waves. As we go from radio waves to gamma, there is an increase in frequency. Here is 5 into 10 to the power 19, here 10 to the power 9. And wavelength radio waves is very highest wavelength 0.3. As we increase goes from radio waves to gamma rays, there is a shorter wave 6 into 10 to minus 12. And energy is also, as we increase from radio waves to gamma waves, the energy is also increases. Now we will discuss one by one. First is one by one all the waves. And first is radio waves. First, radio waves have the longest wavelength of all the electromagnetic waves and has low frequency. And the application of radio waves are to transmit data and used for all sort of, like in TV, radar, radio, satellites, and computer network. In satellites and radar used for navigation. It is also used in medicines to produce images of soft tissues, fat in a body, and a bone. They are used in for making pictures of tissues, fats, and bone. Also use radio frequency ablation. Ablation means heat to destroy cancer cells that are present in a human body. Therefore, these are the application of radio waves. Next is microwaves. Microwaves are radios with wavelength less than 30 centimeter and higher frequency and shorter wavelength. Higher frequency means frequency higher than radio waves and shorter wavelength than radio waves. Application of microwaves is cell phones and satellite uses microwaves between 1 centimeter and 20 centimeter for communication. Micro are used in communication because they can penetrate. These are used for communication in communication purpose because they can penetrate clouds, smoke, and light rain. Therefore, microwaves are useful in communication, but as useful in communication because they can penetrate clouds, smoke, and light. Next is infrared waves. There are three reasons: near infrared, far infrared, and very far infrared. Ultra means ultra high infrared regions. Infrared waves are sometimes, these are classification. Between these are exist between microwaves and visible light. Here, infrared is between microwave and visible light. These are detected by heat and used in heat lab. These are used in daily purpose, daily in life in remote controls to read CD-ROMs. There are also available infrared lamps that use infrared light. Also available digital infrared cameras. Means ये जो digital infrared cameras है, ये pictures लेते हैं, जो ऑब्जेक्ट क्या करते हैं, emit करते हैं infrared waves को. And the precautions of infrared radiation means strong infrared. If the radiation of infrared is strong in certain heat industry, then high heat setting may be hazard to the eyes. This is very harmful for eyes. If the radiation is very high, then it will damage or blindness to the user. It will damage the eyes of the user or blindness of the user. Since the radiation is invisible, therefore special IR proof goggles must be worn in such places. Now next, it is visible. This is the range of wavelength from 390 to 700 nanometer, which corresponds to the frequency 430 to 790 terahertz. The portion of electromagnetic spectrum that human eyes can detect, can see. There are different colors in visible light. Blue has shorter wavelength, and the red is the highest wavelength. If white light, it is a combination of all the colors. In white light, there all colors is present. And the application of visible light is used in medicine, in scanning of laser ophthalmoscope, in endoscopy, and in endoscopy also used visible light, and keyhole surgery. In keyhole surgery. Next is ultraviolet waves. This is the next shorter wavelength after visible light, and the EM waves with wavelength from about 400 billions to 10 billions of a meter. This is a very shorter wavelength, and the application of ultraviolet rays is it is used in tanning beds and sterilizing equipments in medicines. To sterilize any equipment. It is used in medicines. It is used to sterilize medical supplies and equipments that are used in medicals. Detectives use fluorescent powders. It also used for detectives used fluorescent powder. And what is fluorescent? Fluorescent powder that absorbs UV and glows, and to find the fingerprints. मीन्स जो डिटेक्टिव है वो क्या यूज करते हैं, इसको फ्लोरोसेंट पाउडर यूज करते हैं. फ्लोरोसेंट पाउडर क्या होता है, जो यूवी को क्या कर लेता है, एब्जॉर्ब करता है, और ग्लॉस मीन्स चमकता है, और उसी से हमें उसको डिटेक्टिव्स को क्या मिल जाते हैं, फिंगरप्रिंट्स. Also ultraviolet waves means waves from the sun that are emitted by the sun. This helps body to make vitamin D for healthy bones and teeth. This is the also application of ultraviolet rays. And if the quantity of ultraviolet is high, then it will create skin cancer, also creates skin cancer and other types of cancer, damaged tissues. Next is X-rays. X-rays means shorter wavelength and higher frequency than UV rays. X-rays are a high energy source. The penetrating power of X-rays is very high. Therefore, X-rays are used to detect the internal structure of human body. X-rays are used in X-ray diffraction. X-ray diffraction means to find the structure of crystals and any type of objects. X-rays can basically X-ray can penetrate most in matters, therefore used to determine the internal structure of a matter. X-ray also used in medicine because medicines industry and astronomy can cause, if the quantity of X is high, then can cause cancers. And X-ray plays an important role in dentistry and orthopedic investigation, means internal structure of the body. These are the uses of X-rays in medicines, in industry, and in astronomy. Next is gamma rays. Gamma rays are the highest frequency or highest energy electromagnetic waves, and there's a shorter wavelength. They carry the greatest amount of energy because the energy is very high as compared to other waves, and penetrate the most as compared to X-rays. It is used in radiation treatment to kill cancer cells. With the help of gamma rays, These are used in medicines to kill the cancer cells. Inspection tools in industries. Also, gamma rays can check how far a cancer has spread. कितना cancer फैल गया है, कितनी how spread और how well treatment is working. Treatment कैसा चल रहा है, हमने जो उसको treatment दिया है वो work कर रहा है या नहीं. It is also done by gamma with the help of gamma rays. Now the important questions of today's lectures are: what is EM waves? Means electromagnetic waves. Explain their properties as well as production of EM waves. What are different types of EM waves? Means microwaves, radio waves, all explain with application. This is all about today's lecture. Thank you.